Well, hello everyone. My name is Manfred, and today we're going to talk about profiling and debugging strategies for infrastructure, services, and build pipelines. Well, before we get this going, of course, a big thank you to the sponsors of this event. We really like to do what we're doing here, and you enable us. So, big thanks you. So, my name is Manfred. I've been a software engineer and developer for a living for about 15 years now. I'm working in automotive engineering, and my main responsibilities are basically also core development, but developer tooling. So I've basically been CI/CD before it was cool and after it was cool. So I've just been using PowerShell since about 2016, when I got in touch with it by stumbling over Chocolatey, because I needed to do some things with it and kind of stuck with it ever since. So you can reach me on the internet or just come and talk to me later. So what to expect in this session? We're going to show or discover how to detect, how to troubleshoot, and hopefully how to avoid those badly performing parts of the systems we maintain. And the good thing is, in contrast to the universe where we cannot cope with anything, our computers are actually logical. And if we put enough time and effort in it, and if we apply the right strategies, we actually can figure out what's going on. We are able to discover how the systems work and to fix the parts that are not performing the way we want them to do. So I really want to give you something in this session, my focus. And my goal is to give each of you something you want to try and you can try at home or at work. So this is an absolutely do this at home session. Before we really start into it, I've got a couple of slides and then there will be lots of demos. So if it's slow, you're most likely doing it wrong. This is not the title of this session, but it still holds true for a lot of the sessions on this conference. It's kind of a common theme. And what I'm sad about is that most people have come to accept as normal that, our computers are crazy fast on the specs, but they're not actually so sometimes sluggish and not always so fast to deal with. And that is a problem. Because our computers are actually supposed to be crazy fast, but it doesn't always feel this way. So one of the problems that are like the main culprit and lead to badly performing systems is that most people I know are really bad with large and small numbers. And what do I mean with large and small numbers? So everyone can think about what a minute is, what a second is. But when you're going down to the sub-second range, so like milliseconds, I think each and every one of you can deal with milliseconds. But when going to microseconds or nanoseconds, it gets really, really tricky. The bad thing is that our computers are not thinking in seconds or milliseconds or even microseconds most of the time. And when you're doing performance optimizations on a low level, really measuring in milliseconds doesn't make all that much sense. So a couple of months ago, I've been at another conference where I was talking about the performance of a Raspberry Pi GPIO library called Wiring Pi, it was a fun local event, but there I came up with an analogy in how much work such a tiny little single board computer such as the Raspberry Pi with 1 gigahertz can do while light travels a given distance in the same time. So we're talking about 1 gigahertz, which is approximately 1 nanosecond. Basically, it's 1 nanosecond. How much distance can light travel while the Raspberry Pi toggles or whatever? So, I see your expressions, and that's the problem. So it was too complicated. I lost half of the audience there. Therefore, I'm just going to talk to count down from 1 minute to 1 nanosecond and give a couple of examples what an average human can do in that time in comparison to a modern day CPU we've got in our laptops, in our servers, wherever. So, as I mentioned before, 1 minute. 1 minute is the time span we all can relate to, and in a minute I'm about to write a proper email, a text message, or whatever. 1 second is about the time it takes to turn the page of a book. In 1 millisecond, it gets hard. Basically, blinking takes about 1 millisecond, and 1 microsecond is already something we cannot really deal with on a useful basis. Still, it's about the time a muscle needs to contract or twitch, like think about snapping your fingers and actually performing the action takes about 1 microsecond, even though everything else then takes longer. We basically cannot deal with 1 nanosecond. Now, let's head over to the computers. In 1 minute, our computers, yes, what do you want me to do? I can run you a short video clip. When talking AI, we can get amazing answers in 1 minute. We can, just say rendering a video clip. 1 minute, okay, short video clip, which is awesome, realistic looking, no problem at all. So there's billions and billions of instructions being processed in 1 minute. 1 second, also, yes, I can solve an arbitrarily large, complex equation this time. And even in 1 millisecond, our computers are able to perform millions of instructions. Who of you, just give me a quick sign of hands, does run their own servers, racks, data centers? Still some on-premise? Yes, it's great. So when you're doing like network traffic monitoring and you've got basic ICMP ping replies and they're like above 0 milliseconds or above 1 millisecond and you're in your server room, that's already kind of a bad sign, because a 64-byte frame to traverse down the OSI stack, go over 1 meter of copper wire and go up the OSI stack on a 3 GHz CPU takes about, not a very fast but not a very slow machine, takes about 10 microseconds. So it should take not more than 100 microseconds max for one frame to go out one computer and reach the other computer if we're talking about the same data center. Of course, speed of light is a thing. If we're hundreds of kilometers away in another data center, things look different. But as long as you're in your server room, you really shouldn't see like higher ping times. What about 1 microsecond? In 1 microsecond, our machines can do thousands of instructions. They can fetch data from cache. They can transfer about 1 megabyte of data, again, with a 3 gigahertz CPU, with just normal common hardware. And when we're reaching 1 nanosecond, still there. The computer can do multiple things, many things in 1 nanosecond. So I'm just talking about CPU pipeline instructions. Of course, there are much faster speeds if we're going down PCI and so. But just think about it or keep this in mind. Computers are really fast and they can do a lot of work in times we just cannot cope with. Thing is, we are bad with large and small numbers because we are not thinking in these ranges. So I hope you didn't mind the detour. Just a topic that really I have to deal with each and every day, and I'm really into getting our computers to perform as good as they possibly can to provide us with the best possible user experience. Just forgot something there. Speaking about user experience. Is it late? No, I think it's this slide. Okay. There are a lot of big companies that have analyzing the bounce of time users have when their systems get too slow. Like small companies like Google and Amazon have discovered that the bounce off rate increases dramatically, or the probably bounce off rate, when the a web page loading time goes from like 1 second to 2 seconds. I think it's a 30% increase of bounce off rate. Amazon even discovered that a long time ago when they got delays of 100 milliseconds there, they get a loss of income for that category of about 1%. So 100 milliseconds, they figured out, okay, if our system is 100 milliseconds slower, we lose about 1% of income for that special product range. So it's really, those numbers do matter, even in a sub-second range. So we're going to talk about, or we have going to have a look at profiling and debugging. But also, when you're talking about profiling, debugging, monitoring is a thing. So it's not in the title, and actually the correct the correct way of putting this would be monitoring, profiling, debugging, because usually monitoring is the first thing you do. But all those three terms, difference in scope, frequency, granularity, and the goal of it. And I just want to make sure that we're on the same page here when I talk about these terms. So let's start with monitoring and the scope of monitoring. Monitoring is a thing you should basically do all of the time. So it's like a really broad term that not only looks at your specific application, web page, service, whatever, but it looks on your on your machines, like the hardware, the networks, like the operating system, like a lot of system health indicators. And so the scope of monitoring is to ensure that the system is like in a healthy state and you're able to discover badly performing parts or incidents before they appear, or be able to react when you see, okay, there's clearly something going on, I should do something about it. The frequency of monitoring is like hopefully all the time. The granularity, well, it's not really focused on a specific area, it's just give me the overall health of the system. Yeah, and the goal is, as I already mentioned, ensure the system's stable, it's healthy, it's responsive, whatever. When we're talking about monitoring, we're actually looking at a specific part of the system. So we are actively looking, instead of monitoring, profiling. When we're profiling, we're looking at a specific part of the system. So we're actually looking for how does this part, let's say in a build pipeline, which we're going to look at, how does this single piece of the build pipeline perform? Where can we optimize something? And debugging, well, when we're debugging, we're already in a mindset of find and fix. So when we're debugging, we already did some profiling. We know where to look for, hopefully, and we're looking for an error to get fixed. And then we do profiling again, see what changed. And in the overall monitoring, we should see that things got better, hopefully. So before we really get this going, I've got one funny little example from production. Revealing bugs with time series data. So this graph you see here is from my workplace. And thing is, we had this then intern, now coworker, who's been doing some changes in, was responsible for integrating a third party into our Jenkins build instance. And because it was an intern back then and I wanted to get this right and was kind of responsible for it, I said, yeah, let's have a look at how the system performs now before the change and then after the change. And when we looked at the data and how the system currently performs before we applied the change, we got to see this. And who thinks this is normal? Nobody, hopefully. So what we see here is the CPU load for one day on this Jenkins instance, which is the Jenkins master, which the control of all the other nodes. And what we see in this graph, which is not a logarithmic scale, it's really a basic graph. We've got the time on the x-axis and we've got the CPU load on the y-axis. And starting about 6 a.m. up until 4 p.m., the load just continuously goes up. The CPU load of this master goes up. Then it stays the same at about 84% actually. And then it stays the same until 10 p.m. and the load drops. So this is kind of weird. And so this was the state before we integrated a change. Then we went like, okay, we've got this data. How about other data we've got from the same time period? So these are the HTTP hits per minute on the same machine. So you see the HTTP hits went up from like nothing or just a couple of hundred hits to about 1,000 hits per minute in the same time. So when you switch between these graphs, they look pretty much the same. Just the one is the CPU loads, the other ones are the HTTP hits. So we saw a pattern that there's something not right with the system. And this was even before we were implementing the new change. So we had to fix this first. Have you any idea what this could be? So rising HTTP hits and CPU loads between 6 a.m. and 4 or 5 p.m. Usage. Our first guess was, well, we're a decent sized company. There are a couple of people who actually start working at 6 a.m. so they can get off work earlier. And there are basically most people work till 4 or 5 p.m. So that would fit. The nice thing with time series data as this is, you can not only zoom into a problem, you can also zoom out and have the graph plotted for a longer period. So this is what the CPU usage looks like over the course of a week. And you see Saturday and Sunday here, and definitely no one of my colleagues working Saturday and Sunday. So something is really not right with the system. Maintenance task. Well, No, it's way funnier than this. So I have been implementing a build monitor, which is basically a TV we put up in our coffee table that shows us some stats from the system. And as soon as we knew the HTTP hits went up to this point, and we knew, okay, it's occurring each and every day, we just looked at, hey, which HTTP requests are these? We put a little logging in place to basically dump all of the incoming HTTP requests, and it was always the same request. And it was the request that got the data to display for this TV that's in our coffee kitchen to display some build stats. And this TV turns on at 6 a.m. and turns off at 10 p.m. So that's an easy fix there. It was a bad JavaScript that I wrote like 2 years ago, and we've been missing it the whole time. And the system just got sluggish just after lunch. But the people have been actively working with the system. And we thought, when someone told us, the Jenkins instance really is getting sluggish at, I don't know, after lunch. Most of the people are currently working with it and there's lots of build running. So probably that's the reason. Well, we should have better taken a look at this data before, because the fix was really easy to implement. We saw the load goes down. So this is where the Jenkins reboot happened. And the load actually, the great thing with time series data again is that you can look at it at a later time and see what changed. So now we've got the CPU load at the 95th percentile of about 80. Before it was 84%. And now, like a couple of months later, so you can actually see this happened in end of March this year. And now we're on 21st of June. So last week. And we're down to 14% CPU load over the course of a week. So that's like a really nice change. So we've been able to fix this bug that's been long gone unseen, but just looking at time series data, adding some logging to figure out what these HTTP requests are, and problem gone. But if you do not look at this data, it's very hard to find these kind of things and they go unseen for a long time. So for the demo, which we promise you going to go to right away, the setup. So I've done a PowerShell build pipeline. We're going to build a PowerShell module from source with a thing called Sampler. You may have heard it when you've been to Gail's talk. So it's a module he built to basically have some common structure when you're building PowerShell modules. You're having some private, some public scripts that are then get joined into a public module. You have tests in place, all of that kind of stuff. So I'm using Git, and also just I'm really afraid of doing demos with the cloud. So all I'm going to do is offline. And you can all then fetch my Docker files, my Vagrant files from the repository of the psconf EU. So it will all be online. You can try this at home. Also, just is anybody of you using like non-cloud-based CI/CD pipelines in their data centers on premise? Okay, don't worry. I'm going to show you some techniques here, even though I'm maybe not using your favorite tools. All the techniques and the strategy will be applicable for your system, so don't worry there. So I'm using Git as a source code source code control server. So we're using Git. Also, I'm going to push some artifacts there, which is the PowerShell modules that we'll build. I'm using Jenkins as my main CI instance, and I've got like 2 Vagrant VMs, which will be a Server 22 and a Windows 11 VM, which do the actual build tasks. Anyone using Jenkins, even though they're not in there? So a couple. Great. Also, we'll have like Elastic Stack for obvious reasons, I hope, and we'll maybe have a look at Grafana and a couple of other things. So the workload, as I already mentioned, we're going to build a module. I've built this thing called PS Anti-Snowflake, which should be able to keep your servers in the same state, even though you're sometimes not able to do everything in containers and stuff. So when you're, like example, in a build pipeline and you do have to fetch from some software or install some services, PS Anti-Snowflake is actually able to so it's a push-pop state of model. You can push the state before the build, and then you pop the state of the server after the build, and the system will be in the same state. So although I cannot show you like the full version of it, I can show you, we have like a minimal working example, which is able to at least start, stop services and install, uninstall Chocolatey packages before and after build step. So then, of course, our workload contains running some tests after we build the module and then push the results to the artifact server. So all of this, building a module, which is basically just a concat operation of PowerShell scripts into one PSM1 file, then doing the build, this is the build, running the test and pushing the artifact to the server shouldn't actually take that long, right? So we're going to the demos now. Whoops. Uh-oh. Something's going up. So can every one of you read this? Also in the back rows? This is second TV, right? So I've got this little cheat sheet, which is going to help me not blow this demo. So as mentioned before, I've got some Docker containers that I'm just going to spin up now. Actually, I spin up the containers first. Whoop, don't look. And then I'm going to start the VMs. So those basically Docker Compose files for the Vagrant stack, actually Vagrant is quite a big one. But most of them are really, 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 really basic and small. So I've got the Git server, I've got a Grafana instance, I've got a Jenkins instance, and all of these are pretty basic. And everything will be in the GitHub repository, so you can just, if you've got Docker, you can just run them. And the Vagrant images are a bit more sophisticated, so I do pre-install a bunch of software I need for this demo and also for the builds, but again, it's not that much. So now that our containers are running, never mind. We're going to check that they're live. So I've got my Jenkins instance, which I can log into. And I should disable the 1-minute trigger, which I set up to gather some test data for this presentation. It will just take a second. Going to cancel this. It's a good thing I didn't bring the VMs online yet. Yeah. So, and in this Jenkins instance, we just got a build pipeline, which basically says we've got a build job, we've got a test job, and we've got a publish job. So this is actually slower than it should be. So now we're bringing the VMs up. And we should be able to see that those are then online in Jenkins. While those are coming up, I might as well... We're good in time, I'm not going to hurry there. So can only do this once the VMs are booted. So okay, I just showed you the Jenkins instance. Also, there's like the Git, which is our Git server we're using for this. Anyone using Git? Great. So we've got a source code we're going to check out. And also we're using the same repository to then push the build module back there. Another one of our infrastructure services that is running, should be running, is the Elastic Stack. So Kibana is obviously here. Then there's Grafana, It's also nice, loads nice, fast. And there's a Nexus repository, which was not part of the demo until about midnight today, because the hotel Wi-Fi dropped and I have a dependency on a couple of PowerShell modules from the PS Gallery. And when there's no PS Gallery, the build does not work. So what I did was I just installed Nexus and set up a proxy repository for the PS Gallery, which is great because it literally took about 15 minutes to get going. So if you do have like on-premise builds and you do take dependencies on package repositories from the internet, be sure to have some proxy environment. Like Sonatype Nexus is pretty easy to use. You can just add a repository, point it to the public endpoint, and you just pull everything from your internal instance, which is pretty great because you do. Sorry?
I was going to say, so you push your modules to here instead of PowerShell Gallery. You could use this as a repository for that.
Yes, you can also do that. Yeah. So I'm going to push to Git, but you could also push to Sonatype Nexus. You could set up repositories for all different types of things. You can. What's happening? So there's a lot of different things. I do like Sonatype Nexus because it comes easy with Docker. But at work, as example, we're also using ProGat, which is nice. And yeah, just depends on what you're using. So when you're in a mixed environment, I would tend to say probably you're better off with Nexus. But if you're like in a full Windows environment, ProGat's just fine. And all of those things, like JFrog Artifactory and a lot of others, they do support many, many different types of repositories. So no matter if you've got like NPM, pip, Maven, NuGet, chocolatey packages, Docker images, you can basically put them in each of those systems. So now that our VMs are up, just a quick check that they are online in Jenkins. Yes, they are. So I've got a Windows 11 and a Windows 22 server here now. They're healthy as far as we can tell right now. So what I'm going to do now is just check out the source of this awesome module PS Anti-Snowflake. And we're going to have a quick look at it. Okay, this is probably too small for the demo. So if you've been following along Gail's session, Sampler allows you to create this basic module structure where basically you've got a PST1, a PSM1, and the PSM1 is empty because all of the elements from the public and the private bits then get joined together into this module at build time, which gives you bunch of benefits such as the module loading time is much faster than when you're doing dot sourcing. You can actually deploy a single signed binary than having to sign each of those. Also, from my point of view, it lets you focus better on the actual implementation of the single parts rather than if you're developing everything in like one big file or a couple of big modules. It's much easier to focus on the single implementations if you get them like separated. And also it kind of increases that testability because you can really focus on each of those parts. So PS Anti-Snowflake, it's really just a very tiny module. So we're going to build it right away. So there's this build script that gets generated for us. Amazing. Cannot find PS Gallery because a couple of hours ago I did move from PS Gallery Proxy. I'm just going to YOLO this now and try it again. And I hope it will pick up the Nexus endpoint and do the build. This is taking a really long time. So, oh damn it. Just a quick, it would have worked. Would it? I see. Just let me go to airplane mode now to really be offline. It's amazing. So we'll wait and see how long this build takes. Any question in the meantime? All good?
Would you recommend using Sampler for building any size of PowerShell module, or do you only want to use that for more complicated things?
The nice thing with Sampler is that it's able to give you like a really nice template you can then use for whatever you want. So I'd not recommend, or it gets tricky when you've got like already existing module and you want to change or bring it over to like a structured build. Then when you've got when you've got a greenfield project and you're starting over new. So when you're starting with like a new module, definitely go check out Sampler. It gives you so much of nice things. But when you already got a lot of modules or when you've already got your models, you got your builds, you might be better off just picking out the parts that you need in order to bring those over to like the same kind of system. So there's like, I see. We're in the main branch, and in the main branch, we have to be like really, what failed? Something failed. Oh, the changelog. The changelog. Of course, there's no changelog. I'm just going to, I've replaced PS Gallery with PS Proxy. Just going to make the changelog happy there. They're not stashed? Oh, yeah. And we're doing the build again. Code coverage threshold. Yeah. I have to actually mute the changelog. All right. Thanks. That was a mistake. I should have appended it because now it's in the wrong format, I guess. So, changelog. Now it's the changelog in the wrong format. Just throw it away. Okay. We're actually making a meaningful change to the changelog. And now we're doing. Finally, didn't take all that long, did it? So we're able to build this module with the module sampler build locally on my machine. When I do the build, it takes not so long. It's, what are we here? 800 milliseconds. And there are different tasks. So I can do the build, which takes 200 milliseconds. I can do the tests, which take 600 milliseconds. So that lines up pretty much. And I'm done. So I can build this module locally. So where are we in time? Okay. So we've had a quick look at the sources. If there's time later, we can actually check out what the module does, and maybe there's time for debugging it. But now let's do the same kind of things from Jenkins, because we're here to look at profiling and debugging build pipelines, right? So what I'm going to do now is this. There's this build job, there's this test job, and there's this publish job. I'll just start up by opening the build job. This works amazing. Actually, there's something not Yes, that's intentionally. It just takes way longer. So we're going to have a fun time debugging and profiling this system.
You asked for it.
Yeah. Yeah, of course. What should go wrong when you name a session profiling and debugging build pipelines, right? I really begged for it. So...
Containers okay? Are they still up?
But the Jenkins one really is not very responsive, is it? So these are just the connections coming into the server. Jenkins instance is not responding. So I'm going to...
Maybe they bound themselves on network.
Ah, okay. Maybe switching to airplane mode while presenting is not all that good idea.
But yellow.
We'll figure it out. So something did work there. Either it was re-enabling network or it was restarting a Docker container. I really do hope it was the network and you were right, because otherwise, yeah. Something I'm not really prepared. Okay, so now we'll hopefully be able to actually start a new build job. Looks good so far. So we've got a bunch of artifacts from the last successful builds. So there obviously has been something going on in the past. And I'm going now to build with parameters. This is also taking quite long. And we're actually going to look at this. So now I've got a selection of the build stream I want to test. So it's the PS anti-snowflake module. Oh, let me just increase the size of this a bit. It's better for you. So I'm going to snowflakes and build this. So actually now, build just picked, one agent just picked up the build and it started running. And we should be able to follow the logs. So it's on Windows Server 2022, which is just fine. Although I think it's the slower VM in this case because I've got limited resources on this device. But yeah, so there's a build running and it started just now. And it's in a bootstrapping process. So the bootstrapping process we've seen before on my laptop. It took a while, but not that long. Well, actually it took pretty long this time, but there's this bootstrapping process. And if this were at work, and if I were the person to deal with it, I'd already be fed up. Because there's this bootstrapping process, and all of what this build should do is really concatenate a couple of PowerShell scripts into one file and should be done. So I'm not sure right now what this bootstrapping process actually is and if we're going to need it during the for what we're actually wanting to do. But maybe as well the page is not reloading, so I'm getting... Yeah, I'm reloading a couple of times because that is what users do when they see no progress. Actually, we do have a nice progress indicator. We do have a progress indicator that something still is alive, right? But there's not much progress. I'm just checking if Jenkins is still alive, so I'm going to see if I can switch between the output and the page. But yeah, it's nothing much is happening here. So actually my slides say I've got to wait until this build. is finished, which is supposed to take like a minute or so. And I'll just have a sip of coffee and we'll see. Yeah, it already started 2 minutes ago, which is bad. So what I'm going to do now is obviously have a look at the Windows Server 2022 machine. At least it's up. Yeah, I killed it before. There's the Java agent connected to. Well, not much going on there. Still in the bootstrapping process. Great. So if it were the second part of this presentation, I'd just go ahead and debug this. Now I'm going to start another build on the Windows 11 machine, and really do hope it's going to be better. So I'm waiting again until I get this nice selection. This time I'm going for the beta tests branch of the repository. It's kicking off, and since one build is already running on the 2022 server and I only got one executor per node set up, it should now run on Windows 11. And the build is on its way, also in the bootstrapping. How's my system doing? Not too bad. No, not too bad. Okay. I'm not going to do that right now. Okay. So we're in 40 minutes now, and the builds are still running. And I really want to finish the build in order to show you that the module gets built and gets published to the artifact repository. And we can then start to dig into the problems we see here. System really doesn't like me, right?
The program on 2022 machine was a little bit progress.
Let's check back. Hope dies last, but it dies eventually. Yeah. So I do have like a fixed version of this. I'm just letting this run in background right now, and we'll come back to see how bad things are, and we're going to fix it anyway. So, right, what's happening there? I didn't know this was so spot on. So we got to figure out what's going wrong. When you're troubleshooting badly or non-functional parts of a system, or like in this case, there's a systematic approach each of us should follow to not only figure out what's wrong in this current instance, but also to be able to like apply the same structure, the same workflow over and over again to have some checklist, and will just be quicker on the long term. And it really allows us to basically fix all of those kind of problems given enough time. Basically, first we start to gather information about the system. So what's going on? This is what we're going to look at heavily. Then we're going to review the collected data. We're going to find a couple of nice ways to do this. And then we're going to derive actionables and actually fix that system because we really want it to work. And then maybe if there's still hotspots, we're going to debug these hotspots. And for debugging, depending on your specific infrastructure layouts, your CI/CD system, your tasks, it might be a little trickier because on this machine I can actually log into the machine onto the VMs. I can do perf traces, I can do ETV traces, I can actually attach debugger to a running system, which is nice. It might be a little trickier if you're like on a GitHub Actions runner or something like this. But there are still ways to get proper information out of these systems. So the systematic approach, gathering information, reviewing the data, and then deriving actionables and debugging the hotspots will still work anyway. One thing we all have to do is basically, if we see a problem, first sit down and think about what we're going to do. So where should we actually look first and what should we look for? We've had this example at the beginning where we saw some graphs, just the CPU load of a server going up, going down, going up, going down, and we were able to then take another metric, which was the HTTP. So we've got a CPU load, and then with another metric, the HTTP hits, we were able to just compare them. They looked pretty similar, so we've got a correlation between them, and we were able to jump to a conclusion where the problem might be. So just sit back and think about where to look first and actually what to look for. So in our concrete example, in our badly or non-performing build pipeline, we've got a couple of problems. We've got the CI frontend, which was really not fun to work with. We've got the build itself, which maybe is finished right now or not. And then we've got a test. The tests are also pretty slow, I can tell you. It's going great. Still bootstrapping. So there's definitely something going on there. Yeah, we'll figure it out anyway. So we've got a couple of different tools for fixing these kind of things. We can do log file analysis, which is just looking at the logs of the tools we're dealing with. So if the tool does already write logs, great, just have a look at those. If there are timestamps in those log files, even better. Otherwise, we might be able to add them, which is also what we're going to do. Then we're going to collect those metrics like to a common place where we can easily view them. So in this case, we've got like 3 different endpoints, which is one, the Docker image where or at least we've got a couple. I think we've got 4 or 6 Docker containers, but one of them is the Jenkins instance, which basically orchestrates all of the build. Then we've got the Windows servers, which do actually run the PowerShell scripts that is the build itself. And when we basically, when there's like distributed log data, it's really hard to get all of the information in line, to view all of the data in a time series. So we want to collect the data into a common place. In this case, I already told you we've got Elastic Stack in place, so we're going to just push the data into Elasticsearch and draw some nice graphs with Kibana and Grafana to actually see where the issues might be. Really interesting in this case. And also we can do like client-side analysis and debugging. We've all got the web developer console. Basically, doesn't matter what browser you're using, press F12 and you've got a nice developer console most of the time. And we can do advanced stuff such as kernel tracing. If there's like non-obvious and non-PowerShell-y delays which we need to dig into, which we're also going to do, then you can always do kernel tracing. This is like the last resort when all of your other tools are not giving you any insights. You can do a memory dump, a kernel trace, and start over there. A very, very important utility or tool we've got are charts and graphs. So if we just look at this chart, something's not right. And we've got like this one really good broadband connection to a brain, and it's through the eyes. So we're really good at pattern matching and detection. And if we see something like this, we can immediately spot there's something strange. Even so, this is an even better example because here we've got like data that can be filtered by success or failure. So this was a quick sample of it yesterday evening. So we've got like Invoke-Build task elapsed milliseconds. So I'm using a lot of Invoke-Build in my build script, which is a nice PowerShell module to basically separate your build steps into tasks. It's basically a better Psake, if you know Psake. And with a little effort, you can easily push all of this data into Elasticsearch as well, and then like filter. Okay, please tell me what are the tasks that succeeded, what are the tasks that failed, and how long did it take. And if we just hover over one of the categories, like here the failure, we can easily spot that when the time went up, we had a lot of more failures than when the time was down. So we're pretty good at connecting different metrics when we see them visually. If I put this data into a table and we've got like 400 rows with success and failure, and in the next column we've got like the time it took. If you've got this 400 row table, you wouldn't see anything basically. But if you put it in a graph, you're able to draw some conclusions pretty quickly. Another really, really good visualization, especially when dealing with performance problems, are flame graphs. Who of you know what flame graphs are? Have been using them before? Okay, a bunch. So, flame graphs, this is already pretty deep, and we'll be looking at it when we're doing like kernel tracing, but also if you're using Pesta. So, Jakob shortly mentioned after Ask a Question on Monday. With Pesta, you can also do like flame graphs of the tests you run. Not Pesta, it was Profiler. So what flame graphs actually do is they aggregate the call stacks of a trace, of a given trace. This sounds rather complicated, but it really is easy. So when you do tracing, you basically look at the application, the kernel, whatever, in a given interval. So let's say you're tracing at 1 kilohertz, which means you're doing 1,000 like lookups a second, and you basically look at the current instruction pointer of your operating system, of your CPU, and you basically remember the call stack. And you do it like 1,000 times a second. You collect the trace, and after that you're merging those call stacks. Still, it sounds complicated, but it will get really easy soon. So when you now have got this application and you've got a function A and a function B, okay? And in this trace, you saw function A for 3 times and function B for 1 time, then function A will just be 3 times wider than function B. So your CPU has been 3 times as often in function A as in function B. Remember, this is not really exact because it's just sampling 1,000 times a second, but it still can give you a pretty good hint or overview of where your CPU is wasting time or not. So where your actually CPU time is going to. And since this is call stacks, you get this top-down model actually. So when you're looking at flame graphs, and this is what I wanted to know you, always look at it from top to bottom. So in this example, the CPU only really did work in what is up on the flame graph. So it doesn't matter if there is some TLS connection new down there, the CPU did waste time in malloc. So this is what actually took the CPU time. Okay, so now we're back to the demos. As we're 50 minutes in, which is approximately half the time, and I need to fix a demo, I think we're going to have like a 5 or 10 minutes break. Go grab a coffee if that's okay for you, and just be back here we start again at 11, so a 5 minutes break. Thank you. And I'm going to fix a demo. Oh, it's working now. It fixed itself, but it takes like... I'm going to have one here. Thank you. Oh. So it's building now at least, and I've got the version that's going to work. And just... We're coming to good paths right now. Sorry for the problems with the demo.
Ja, ich habe hier jetzt im ersten das Ding ich habe hier die es gibt genug verschiedene Vorgehensweise, aber ich nicht gut aus. Ja, also, das war hier weiter, dann Augustine, das war die Rechte. Ja, das ist sozusagen, was das ist denn als das ist halt eigentlich Konsequenz. Insofern mit allen Denken, aber auch Berufserfahrung hat, einmal gut auf der Programm und eine Teile von der Person, die Individuelle Formulierung gibt es überhaupt nicht. Das war ja. Dann wollen Sie hier also ich habe hier so mal nur weit weg. Dann kaufe ich das da. Das ist selber uns. Nimmst du nur in der Land, nimmst du euch die 7, folgt der letzte. Das wird aber nicht, oder weiß nicht, wenn
So the demo is kind of working again. Just waiting for the signal from the AB. Are we good for the recording again? Okay, great. So after this quick break, if you just look at the build times here in the Jenkins instance, this is what I'm aiming for the first demo, which was about 3 minutes for all of it. Then the working part should be approximately 20 to 30 seconds. And this is where we're now with the working demo. So we see the spike. It just takes about 16 minutes now to build this thing. And we're going to really get this back to where it should be in the next part of the demo. So just to show you what didn't work before, we now got this pipeline here, and the build run, the test run, and the module got actually published to the Git instance. So when I now open up Git and look at PSNT Snowflake packages, there are now 2 more package versions that just got pushed to this artifact repository. So the versions are here. And yeah, 7 and 3 minutes ago, there have been pushed 2 new versions. So what I'm doing in a lot of CI/CD pipelines is that I actually, when you're using things such as Git version or any type of semantic versioning, you probably end up with the same version numbers, which is good. So when you using Git version, it usually gives you like the version closest to the next major branch or major tag in the current branch. And then it depends a pre-release tag if you want to, based on the number of commits, you're like ahead this last tag or you see in your history. So what I tend to do is that I put some Unix timestamp in the version anywhere here, so I can actually rerun the build pipeline, rerun it, and have the artifact being pushed to the artifact repository, because otherwise it would just say, I'm not taking this version, I already have this version in my repository. So that's a nice trick to just add some Unix build timestamp in there if you're wanting to be able to repeat the same build and still have the artifact pushed, even if it already exists with the same version in your, or with technically the same version in your repository, because since it's a pre-release version, doesn't really matter at all, and it won't be applied to production releases. We're going to start the demo. So, in the previous slide, a couple of slides actually, we now want to figure out what's going wrong. And therefore we need to gather information, and then we're going to review the collected data. So when we're gathering information, how can we gather information? Did I just close all of my VS Code instances? No. I want to take a look at this one. So I've got this little cheat sheet, and my infrastructure is already running. We've built it, we tested it, we haven't pushed it, but we're going to skip this now. Yeah. So, how to do profiling in PowerShell? How to do logging in PowerShell? Actually, I think we're going to start with logging first. So I'm in the wrong slide here. So when I'm doing profiling, when I'm doing monitoring of a system, when I'm adding monitoring to a system that's not behaving the way I want it to do, then I try to actually gather as much information as I can without modifying the actual build scripts, the actual meat of the build itself. So I try to actually inject my logging, my metrics collection into the already existing build, which is nice because then you can basically apply it to all of your pipelines, no matter how old, how new they are. If you do have to support legacy versions and you do have some legacy build scripts in there, you should not actually change, or which do not use like the latest and greatest tools. It's really cool if you can also inject like the same logging capabilities into those old pipelines and the new ones. So what I typically do is I write a lot of proxy functions. And this might not be like very pretty, but PowerShell scripting is like powerful enough to enable us to do so. So as mentioned previously, I do use a lot of Invoke-Build. And Invoke-Build is basically just, you can use it as a module, but basically there's this one Invoke-Build script you're calling, and then there's this domain-specific build language where I'm just going to show a script. So this is a valid Invoke-Build script. Just these tasks. The default task is dot. The default task depends on bar. And task bar just writes some output and sleeps for some time. Then there's this task foo, and it has a dependency on bar. So foo will build bar or execute bar before it runs its own script block, which is this one. So I'm just going to demo it. Of course. Let's put it this way. I've got Invoke-Build here, and I've got this Invoke-Build.ps1 script. And I'm going to pass in my test and source demo build ps1. I'm just going to run it this way. So the default task build just built task bar. It printed hello here. It slept for some time and it finished. So this is actually what we get when we Invoke-Build the script without any additional arguments. Now I'm going to tell it, okay, please run task foo. And it randomly fails, is what I forgot. So I'm just going to do this for 100 times. Yeah, and it just failed. On the first run. Yes, on the first run. Okay, so pretty random. So this is what Invoke-Build is. It's really just a task runner. Okay, it's a great task runner, and this is also what Sampler gives you for your build scripts. So your build is structured into different tasks, and when you run the build script, those tasks then are run. Why am I telling you this? Because I am going to inject my logging logic metrics into the existing system without actually touching the system. So what I do is where is it now? Invoke-Build PSM1. No, I'm in the wrong repository. Am I? This is the right file. Okay. So I do a lot of proxying functions. Has one of you done like modular function proxying before? Okay, this is fun. So this function is called Invoke-Build.psm1. It's like the exact same name as the original Invoke-Build module has. So if you're loading this module and then importing Invoke-Build, it won't get important again unless you're using force, but that's a whole nother story. What I'm doing here is I'm removing the module if it's already loaded, and I'm importing the module myself. Then I'm going to importing simple module. This is another thing. So I'm actually going to remove the module Invoke-Build, and I'm just going to basically really remove it. Then I'm going to create an alias for Invoke-Build original. And then I'm going to declare a function Invoke-Build, which is also what Invoke-Build, the original Invoke-Build, declares and exports. And notice how this is not an advanced function, because I really, really want to be able to just pass all of the arguments that I get in this function just along. And what this does is it actually just wraps around. This is all basically just... So what it really does, it calls Invoke-Build original with the arguments that have been passed. There has to be a little trickery because of the result key, because I want people to be able to use my Invoke-Build just as they were using the original ones. And if they're passing the result key name, which is -result, to have the Invoke-Build result saved into a PowerShell variable. Just let me show you. So -result hello. And now I've got this variable hello, which contains all of the information from this build. So there's information there on how long it took, as example, the elapsed time of this task. And if it was successful, what the dependencies were, a lot of things. If someone passes this result, I do not want only to be able to use this result to push it to my logging instance, but I also want the user to have like a seamless experience and not care about that there's a proxy in between. So there has to be a little of trickery to be able to get the result and also use the same variables as the user provided it to me. But basically it's just called original. But this is not the monolith block. So I'm just calling original. But after this has been done in the finally block, so it's a try finally idiom, I do not care if there's an exception or not. When it's done, I'm going to create a result object. And in this result object, I am going to go over the tasks that have been executed. And for each of these tasks, I'm going to add like this tiny little PowerShell object, which contains the name of the task, the elapsed milliseconds, and if it was successful or not. And then I'm going to push this to a log instance. So when someone uses Invoke-Build in their scripts, and this Invoke-Build has previously been imported, then actually all those calls from this build script that are going to Invoke-Build will pass this proxy, and then the log output will be published to this log instance. So PowerShell function module proxying is one really easy way to wrap around. It's not that complicated, and it really allows you to just plug in some additional information gathering endpoint in your existing systems. Yes, please.
Yeah, I've done a similar thing like you're doing now. There's like you can still make it an advanced function. There's like value from making arguments,
yes,
where you can just bound anything that isn't bound to a parameter that you have declared. So you can still make it an advanced function without.
Does it? Okay.
You get a big array of everything.
Yeah.
The argument that's passed to the function that's not bound to something that's defined as a parameter.
Does it work when you've got like the? I tried to do it before. Let's have a chat about this afterwards because it sounds really interesting. The thing that I was struggling with when using the unbound variables or the unbound parameters, I want to pass both the bound parameters and the unbound parameters and be sure that the receiving function actually is able to bind the parameters if are in the unbound parameters. So I would have to look at the AST of the function I'm going to call and rebind all of the unbound parameters, or at least that was I was bound up with, and it was way more complicated than just using a non-advanced function and just begun with it. But let's talk about this later on. I'd be really interested into hearing how this could be done better. So proxy function. So far, so clear. If you looked at this, I'm also including not only the results from the Invoke-Build task, but also I'm including some metrics base info. And this metric base info is like the least thing you should, in my opinion, include in all of your log messages, or in all of your logs, which is what user on what machine in which PowerShell version did run the task. Why do we need this? We need this because not all of our machines, not all of our servers are the same. They're very different. And when you look at the time series data and you've got like a lot of spikes and a lot of jittering, like in load, in memory load, whatever, it may just be that all your data points is coming from different machines and you're showing them in the same graph. So then you should probably create like one graph per machine or per hardware generation at least to get some consistency. But we'll have a look at this pretty soon. So we have had a look at the proxying function, but this proxying function Invoke-Build. Actually, yes, I'm just going to comment out the Invoke-PostHomebrewLogging thing, and I am going to import the module and do this again. So import module test and source Invoke-Build. Now get command Invoke-Build. I see I've got the command, the function Invoke-Build. And when I now do the same thing again, no, I probably shouldn't have used the script in this case. When I do Invoke-Build again, just for task foo, looks the same to the user, right? But when I now, yeah, it's another function that has the pass-through switch. Okay, when I would now dump my log object, this works great. Oh, thank you. Chess is actually paying attention. So now it failed, which is nice because it should randomly fail. But now I also got this output at the bottom, which tells me, okay, the PS edition, my username, my host name, and a bunch of things in an array. I'm going to assign this, and now I can actually look at it, and I see that there have been 2 entries, which one of them took 25 milliseconds, another 27 milliseconds. I've got the names and I've got the success of those. And what I want to do now is basically make this data available so I can not only look at it in the console or maybe in a log file, but I can actually see a time series of data. So what I tend to use is Elasticsearch. Because it's not really a time series database, but it's really easy to adapt to act kind of like a time series database. And when you've got a lot of log data and want to have a simple endpoint, you can just literally throw your JSON and your PowerShell objects at it. Just takes them, and you can easily, it's pretty easy to expand, and it kind of acts like a log time series database, although it's not. So if you're pushing like gigabytes and gigabytes of data, you better choose something different, most likely. But if you're just, as me, pushing data from build pipelines and especially doing this when troubleshooting, then you'll probably be fine. Also, Elasticsearch is like really easy to get them on each machine. Like you've got Docker, spin it up, it's there, you can push data against it. Anyone of you using like Prometheus, FireDB stuff? Yeah. At home for home automation. Docker monitoring. Okay. Right. Yeah. It's cool. So all of these tools that I'm using are my preferences. So if you're in the Microsoft universe, if you're doing with Power BI and stuff instead of the Elastic Stack, that's great, and you'll be fine. It's just this example that is supposed to show you how easy it is in PowerShell or with PowerShell. With basically, this is not bound to PowerShell, and we'll have another Groovy example if I make it in time. Just the important thing I want to emphasize here is it is able to add monitoring, to add logging into our existing systems without actually touching the workload. And what's even nicer is that, let's put it another way. Who has done structured logging before, or who knows what structured logging is? Okay, not so many. So when you're logging, when you're gathering data, it's not only about the gathering the data, but also doing something useful with it. And when you've got millions and millions of lines of text, it's pretty hard to fetch out the data that you're actually going to need. Therefore, there are plenty of tools that can help you with it. It can be done in post-processing, and there are things like Logstash that can actually take some scripted functions to go over all your Apache Nginx logs, whatever, and split up those log lines into the actual proper log objects, which are like the timestamp, let's stick with the Apache example, the origin host, the HTTP like response code, and the URL that was requested, the source IP maybe, the destination server IP. Then you've got like these 6 different properties of one log line. And you actually want to break up those log lines into those properties, so you then you're later on be able to aggregate the data based on those properties, to search for the data based on those properties. And Elasticsearch, as example, is really good at that. So let's stick with the Invoke-Build example for now. I've shown you the metric space info, which is at least some information we can now use when we're going to look at the log lines. And then there's this Elastic PS1 file. So just to emphasize how easy it is to get going with Elasticsearch, I am going to go to the Kibana dashboard, which is what comes with the Elastic Stack. So this is it's barely anything in there right now. And I am which log did I use? I did use the homebrew metrics. Did I use? Which did I use? Also the homebrew logging. Well, I'm not going to delete this index because if something fails, I still want to be able to look at the data. But when we get indices, if we look at the indices we've got here on this Elastic, it's Jenkins index, it's the homebrew logging index, and it's got like 800 log entries, and it's got like 419 kilobyte of data. So there's literally nothing in there yet. Oh, I know, it's the mysteries hack, right? Okay, so I'm going to delete one of the indices I've got here. Delete. So okay, I've actually deleted this index, which went by the name mysteries hack, and now it's gone. Okay, so we're now want to create some basic logging for our PowerShell scripts, and what I came up with, and which is hopefully in our cheat sheet. Yes, that's the index. So I've got this Invoke-PostHomebrewLogging function, which is a really complicated one. So what this does, it invokes a web request. That's literally it. All the rest is basically authentication. So we've got a URI, which we're obviously pushing against. We've got an index, which in this case is mysteries hack. We've got a password, which is super secure in an environmental variable. And then we've got some data. The data that you want to push to a structured logging endpoint should always include a timestamp. Although I really do trust Elasticsearch to properly expand the indexing as I need it, because I'm going to push a lot of different things against it, I always create a mapping for a timestamp, and I exactly tell Elasticsearch how this timestamp is going to look like, so it can so it can pick up the data and sort it accordingly. So this is the format I'm normally using, and then we are going to push a JSON object against it. So the post parameters are looking like this. We have the URI, we've got the index. We're just pushing documents for now because we're keeping things easy. Then we're posting JSON. And since we're using PowerShell, we take our object, which is basically a hash table most of the times, and I'm converting it to JSON with some depth because, if you're doing this thing, you know why. And I'm going to compress it to just keep it short. And I'm skipping the certificate. Please don't do this in production, but obviously test environment. No valid SSL certificates on this machine. And what I also like to do is to set the connection operation timeout as slow as possible. So obviously 1 second, it's pretty quick. It's really not. But then you also got like DNS lookups and stuff, which may take way longer than this timeouts. And even though you set a timer to 1 second, your machine might as well take 15 seconds to actually realize, oh, there's an endpoint there because I wasn't able to look up the name. Might tell the PowerShell team about it. Would be great if we'd get some functionality there. So, and then actually all we do is we invoke a REST method, which is a post against this endpoint. And here's where I implemented this pass-through. Some of the times we want to get the feedback because Elasticsearch, this endpoint, will actually tell us the document ID of the document it just received, so we can have a look at it later on. So this Invoke-PostHomebrewLogging function takes a log object and has a switch, so not really nothing there. But I now have to .source test and help us source Elastic secret, which do contain all the secrets we need for this. And I will also need to put the mapping for the timestamp here. So actually I'm going to create this index and do this one single thing to ensure that all of our log entries will have a proper timestamp. So I'm going back again here in the DevTools, and I am going to, this is an old example, mysteries hack mappings. Then I just deleted the index, which is fine. I'm going to create a new one, and I'm going to create a mapping, and now the mapping's there. So actually, let's do a get now. So there's the index mysteries hack, and it got one mapping for one property, which is a timestamp, and expects it in this format, and this matches with what we've got in the PowerShell script. So now we are able to actually get this function, was PostHomebrewLogging, and I'm going to invoke PostHomebrewLogging. I'm going to pass an object or a hash table. Name ist gleich me, message is please work pretty please. So, and probably did something. So this went really fast, which is what logging should do. If you're adding a lot of logging to your already badly performing systems, be sure that your logging really does not take any time at all, if it's possible. There's PS Framework, which Friedrich is going to be happy to talk to you about it, which can do a lot of asynchronous stuff and also logging. And you can do like asynchronous logging with PS Framework that literally just runs in parallel, and you'll be good. You will be, so it's a nice way to implement asynchronous logging. So now we're going to look at the log data we just sent. Mysteries hack. Mystery hack. Explore one matching index. And there's literally this one document here with a timestamp, a message, and it works. So we've actually pushed some data into Elasticsearch, which is fine. But now we're going to push a bunch of objects in there. So I'm going to push 999 objects. And what I'm doing here is I'm setting a name, some lengthy text, and a couple of tags. Notice how this is totally not thread safe, because I'm always getting like the current date in milliseconds. I'm doing a modular 2, so this might and hopefully will change between those between those calls. And sometimes Hamlet will say something, and sometimes the current environmental variable name, the name, will say something. And we're going to post this data to our just created Elasticsearch index. Just let this run for a second. Shouldn't take that long. Get Hamlet is a wonderful PowerShell implementation to get some non-lorem ipsum but funny strings. So I have to give a shout out at this point. So there's my help pass. So yeah, what Get Hamlet does. So there's this page called netfx harmonics, and you get funny. If you need strings for testing, and you do not like lorem ipsum, you can just say get Hamlet and get 10 different words that do sound like some Hamlet code. Okay, novel. So now we do have a lot of messages in here in the last 15 minutes. Well, we can go to hours, but we just created this index, so it does not make any difference. We can view the lengthy text, and we can view the name, and we can view the tags. So now we've got a bunch of information in our logging system, and it's structured. We can filter by name. We can see what Hamlet said. We can see what Bill Cipher said. We can say which tags they were, and it's already a central point for logging. So if you've got your system split up into multiple nodes, you really want to be able to have a single point where all your logs come together and you can search for and filter stuff. I'm running a bit short on time, so I think I'm going to skip this part of the demo where we actually break down those log entries and come to it later on if we still got time. So you just saw Invoke-PostHomebrewLogging, which just takes literally a hash table and pushes to endpoints, and then it's on an endpoint. It's really easy to do. And in combination with, that's what I actually want to show. In combination with proxy function, like this one we've seen earlier, we can actually now push the data from our Invoke-Build script, from the build task, and push it into the logging system without any changes to the original system, to the original build scripts. So just to be sure, I'm going to get rid of everything I just loaded and see how my VS Code explodes. Nice. Okay. And now I'm going to do the same thing again, just I re-enabled this Invoke-PostHomebrewLogging down there. Where does this push against if it's... Yeah, okay. This is a correct fallback address because I just changed the index and I wanted to show that that goes to the correct endpoint. So I'm going to import my proxy Invoke-Build, and now I'm going to Invoke-Build again, just task foo, and it ran through. So there's nothing changed from the user side of from the user perspective. But if we now go into this homebrew metrics, and literally nothing there because I do not have this filter, and I look for just this timestamp. Yes, that's nice. And I look for the Invoke-Build tasks, and I look for the success, and I look for the elapsed milliseconds. So now I've got one log entry just created with bar and foo, which are true and true, which both succeeded, and I've got elapsed time. Just going to modify the example a little bit so you can see it's actually coming from this demo. I'm now, let's fail it, it doesn't matter. Now we're sleeping between like 100 and, that's 3000 milliseconds to have actually some difference here. I'm going to Invoke-Build. Doing this a couple of times. We should be able to actually, now it failed, which is good. Okay, and now if we refresh, we can actually see a lot of entries with a lot of different times for the Invoke-Build tasks, and now we're able to do some dashboards and visualize the results. And last 15 hours is like way too much now. So we're getting closer to something we can work with. Still not good. But yeah, we can now see here at least the success rates, the failure rate. So there's been like one failure, which took about 1.5 seconds, and all the others were a success. Remember that this is like fairly random data, so there's nothing to be seen here. Just wanted to show you, okay, now we can put this into a graph. And I'm really running low on time here. So what can we do now? We are able to gather some metrics from an existing build script that in this case uses Invoke-Build. But I said as long as you're using like PowerShell based build pipelines, it's really easy to like plug these things into existing systems. So no matter when you're using Invoke-Build or Psake or Pesta, even when you're using Profiler is a little trickier than that, but you can just take the results and push it somewhere without actually changing the user's workflow. So when we are dealing with a CI system, we can typically modify the way our builds are kicked off. So in Jenkins, it's fairly easy. Of course, we can use Jenkins files, which are then hopefully in a source code control system. But for the sake of this demo, I just created some freestyle jobs, and I am able to actually modify the source code directly here. And what I did already in this for this demo is that typically this before we're going to analyze it, it would look something like this. So we're doing some, as example, git clone, and hopefully there would be some logging, which okay, I'm now going to clone. And then later on there will be some logging. Okay, now I need to fix up the version so we can actually push multiple packages to the same repository without having the repository tell us that the version already exists up there. Then we're probably telling the user, hey, I'm going to bootstrap the build, and hey, I'm going to run the build. What I now like to do is create these wrapper script blocks, which is basically some kind of really basic domain-specific language. And this type of build scenario domain-specific language, which I call like the monitor blocks. So the monitor block, in this case, just let's look at the source. Again, some 50 lines of code. Just takes a script block, a description, and a logging function, which is nice, and again, a pass-through switch. So this monitor function actually has one purpose. It takes a script block, and pretty similar to measure command, it just tells you how long this thing took. Additionally, we want to have some description so we know what we're tracing. And this information, so what did we just measure and how long did it take, we're going to push to Elasticsearch. So at the end of this, again, with a try-finally pattern, we're going to get some metrics-based info, and we're going to invoke the logging function. So this is already a bit modular, so you can actually swap out the logging function. So if you do not have Elastic endpoint, although the default in this demo is that we're going to call the logging function, which is Invoke-PostHomebrewLogging. So this works pretty, yeah, it's just, so we can actually do monitor something. We can say hello psconf, and we have to provide a description. So this is just like the most easy. Yeah, I should actually import my simple monitoring module. And it says hello psconf. And it hopefully measure. When we measure it, it doesn't take no time, but it takes about less than 20 milliseconds, which really isn't all that good, but yeah, it will work out for this example. So now we have this data we just produced in Elasticsearch again. I do now have a bunch of host entries, I do have descriptions, and I do have the total milliseconds that the actual workload took. So it took 0.7 milliseconds for this string to be propagated to the receiver, which in this case was the host, the PowerShell host of VS Code, and the other part was itself the web request to Elasticsearch. So what would normally take 0.something milliseconds now takes 19 milliseconds because I'm measuring it. Just keep that in mind. A web request is always pretty expensive, even though if it's on the same machine, just in a Docker container. So probably if you have like thousands and thousands of lines of build script, do not surround each and every of these lines with an own monitor block because time will just explode. Although it would be nice to see where time is going. Exactly. So unfortunately, previously, the build has not been working, or at least it seems like it hasn't been working. Fun fact, it has been working. It just took like really, really long to get over the bootstrapping phase. So when we take a look at the data from Jenkins, it tells us the build took 16 minutes, which would, in my preparation, it took like 3 minutes or a minute or 20 seconds when it would have been done with my optimizations. So I'm really curious to see how, where this time went. So as the monitor blocks already have been in place when we ran this build before, we can drill down here and see where the problem was without actually looking at Jenkins logs. Also, that's one thing that I told you, but we have not yet seen. When we now look at the logs of this build that took 16 minutes, we're having a really hard time to figure out where the time went, because there are literally no timestamps in here. So when you're creating log messages, even though we just called the build script from sampler, there are little to no timestamps. What actually is there, which is nice, is the timestamps from Invoke-Build. So sampler uses Invoke-Build, and Invoke-Build itself prints some timestamps about this, the tasks it ran. So here it told us that the build itself took, 1 second. But if we go further up, yes, that's actually a great example, because the bootstrapping process is not in Invoke-Build. Yes. So we have seen it because the build has been stuck at the bootstrapping process, but we do not know in this example where the 16 minutes come from, because when we even when we look at the very last line of the Invoke-Build output, which said, okay, all of the build took 1 minute and 33 seconds, which is way too long. The whole thing took 16 minutes, and I really want to know where the time went. And because we've got like these monitor blocks over the bootstrapping phase, over the git clone phase, over the build phase, we can actually now drill down and see that data in Elasticsearch. So we are going to look at Homebrew metrics. We are going to look at, okay, this is a monitor block, so I'm going to look at the host name. I know this build was on filter. Host name is, which host did it run on? On Windows 11. So I'm going to specifically look for Windows 11, which is the host name is VW11, which is not Volkswagen, obviously, but virtual Windows 11. So we've got now only the log entries from this. I'm, of course, going to add the timestamp, which is always interesting. I want to move this around, left, the host name. Then I'm going to add the description, and I'm going to add the total milliseconds, which is basically what this monitor block gives me in the Homebrew logging. Thing is, with this, I have to sort it. Okay, I do not have a filter right here. I'm going to sort it based on the timestamp, and I'm going from new to old. Okay, so now that's starting to look better. We've got bunch of data points here, but I'm already having a hard time to figure out which ones are the really, really huge outliers. So what I'm going to do is I'm going to just take this data and put it into a graph so I can easily spot the spikes at the end. Also, I already see that bootstrapping takes way longer than, as example, building. So I could just filter and have now the bootstrapping phase filtered. And now I can maybe spot it in this table. No, still not really. So I'm going to go to the dashboard, and I've got my demo build dashboard. I'm going to look at the last, maybe not 15 minutes, but 2 hours. And I see that the bootstrapping took like forever. To be fair, in this scenario, when we've got like 16 minutes for the build, having milliseconds may not be the best idea, because it's harder to read. But what we can see here is the build was pretty short in comparison to the bootstrapping phase. So even though it did not went to plan as I'd liked it to, we can see that there's a huge difference. So we actually just ran two builds, one on Windows 11, one on Server 2022. And so we, in theory, should now split this up, but then we would only have one data point. So I actually like this more in this case. And we see that the bootstrapping phase was just beyond what should be what's reasonable. And the bootstrapping took way longer than the build itself. So what we'd now do is drill down and see why the bootstrapping actually takes that long. And if the bootstrapping itself would be done via Invoke-Build, we already had data, because in the Jenkins build, I did, in order to be able to do my monitor blocks, I included my simple monitoring PSM1 files, which sets actually the proxy function in place. So this actually activates the proxy function for Invoke-Build, which then is picked up by the build script. So if the culprit for the sluggishness of this system were in Invoke-Build, in the bootstrapping phase, then we already had the data we want to. Unfortunately, we do not have. So what we do now is we come back to, so there's this git clone, there's this bootstrapping. So we see from the data that this line has taken like ages in the whole process. What we now do is we come back to the documentation of sampler and see that this call actually might not be the best thing we can do, because there is this thing called module fast, which is way faster than using PS resource get when cold booting a system. And what this Jenkins job and all of this pipeline basically is doing is deleting a workspace before a build starts. Because most of the times actually you want to have clean builds. Because servers do, at least the servers I manage, do a lot of different build tasks, and I do not want the Maven artifacts from one build to interfere with another build, which is a completely different project. And I do not, especially when doing release builds, I want to ensure that all of the dependencies of a build actually come from an internal repository and are not just some leftover cache files. So I really need to hurry up here. Okay, so now we just fix our dependencies. Not dependencies, we just use module fast instead. And now I would rerun the build pipeline and would see a significant decrease in this bootstrapping of the build. Yeah. So we're basically running kind of out of time. So I'm now showing you what the fixed version or a hopefully much better version of the build would be like. So I'm going to start this job called build new. This job build new has got exactly the same parameters. I'm going for beta tests again and pray the demo won't blow up this time. Actually, what I'd like to show you, if you're interested, is how to drill down into problems that are not catchable by this kind of pattern. So when you do like getting a timestamp before and after a build or before and after a task, then you can say, okay, this executable, this whatever has taken that amount of time. But you actually can't see where the time is spent when you're dealing with binaries, right? And a lot of times it already has been successful in my case to use the Windows event tracing. Do you know it? Has anyone used it? That's great. So Windows event tracing, kernel tracing allows you to actually look at the kernel, and you can do this in production, and you can collect a trace of what's going on in your system. And then there's this Windows Performance Analyzer, which is a nice UI that you can use to do things like flame graphs as examples since I think a year or so. And then you can actually, so I'm just going to tell you, I've got like 5 minutes left, I think. And so this build still is slower than I would want it to, but it's already finishing, I guess. So we are going to need one of these slow builds again. So I'm going to start it, and then we're collecting a trace. And no, actually, let's make it simpler. I have created a trace just the other day. Was it on server or on desktop? I think it was. So there's this thing called UI for it's here. There's a thing called UI for ETB. I'm not quite sure how to increase the size on this. I'm sorry, you'll have to bear with me. So UI for ETV, I think it's from a guy called Bruce Dawson. He works at Google. He does a lot of event tracing. He's got this amazing blog called Random ASCII. So check it out. And he does tutorials on event tracing. So when you want to do event tracing, basically you load up UI for ETV, you do a Choco install for UI for ETV, then you are able to start tracing. Now, actually what's happening is that all of the kernel events are going to a buffer, which means there's a lot of data. So be sure to close down all applications, all processes you do not need for the thing you're actually looking at. And when you're done, you save the trace buffer. Now this thing goes over the data it collected and merges it into a pretty small, in this case, a 7.6 megabyte trace file, which then can be opened by the Windows Performance Analyzer, but just double-clicking on it. So now I'm opening a trace file, which I prepared for this demo. I actually wanted to show you live, but unfortunately time has gone anywhere. I don't know where. And now we are able to drill down and see what happened. So during the build, in this case, I'm just going to close all the windows. There's this weird pattern. Even though the build literally does nothing, there are these spikes in CPU load. And it kind of looks similar to what we've seen in the beginning. And we're able to like zoom in on problems and see where the time went. And there's this weird executable called IOG. And if I look at it, it is actually an IO gobbler, which we used on all of, not this version, obviously, but IO gobbler often is used to just redirect streams like standard out to whatever, standard air to whatever. And with certain versions of PowerShell, like Windows PowerShell on server 1809, you needed such a thing that ensured that there was a console host attached to PowerShell, because if you just like ran a headless build or a headless PowerShell session, and some of the tools that you invoked from PowerShell wrote to standard error, which a lot of the Unix tools do, PowerShell would just blow up with a terminating error because there wasn't a console host attached to PowerShell, which was a bug in Windows PowerShell on Windows 1809, which is fun because it's a LTSC version. But yeah, and it won't get fixed in this version. So you need to have some proxy in between that redirects all of your outputs. And when you now drill down to this and you do like a flame graph, so I'm going to filter to actually be able to do this in time because this is really a slow machine. And now I'm going to have a look at the flame graph of this process. This is the last thing, and then promise I'll be done. Yes.
It's not a problem for me, but
okay, I know. We'll have lunch
thank you.
really soon. So now this is the flame graph of the thing we're looking at. Actually, filter to selection, it's this one. And as I told you, just look at the thing from top to bottom. And there, if we click at it, we see that it's spanning huge amount of times in a function somewhere in itself. So what we can actually do now, if this is a thing we have the pre-built the PDB files for the debug symbols, we can actually load the symbols and see which is the function that all of this time is going to. Then we can also, if it's a .NET, if it's a PowerShell function, we can attach a debugger to it, which I'm not unfortunately going to be able to do. But if you're interested in it, come to me later on. I'm going to show you how to drill down in this, figure out what the actual problem is. In this case, a really stupid programming mistakes. Just talking about, I don't know how much you know about algorithms and stuff, but often we do like really bad sorting and filtering with a quadratic or in this case, maybe an exponential runtime behavior. And this then just blows up. And it can be really easily fixed. So the demo is basically done because I know you all want to have lunch.
To be able to trace like just working with the mg-graph module has been a pain for me.
Yes.
Loads like 2 minutes every time you need it. To be able to trace like the module itself to see why it's loading.
Yes. 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 But, okay, so, okay, actually, let me answer this in the end, right? Okay, so the takeaways. Although I wasn't able to show you anything, not everything. I was able to show you a bunch of things, but I wasn't able to show you everything I prepared. The takeaway for this session, which I want you to be able to do at home, do at your workplace, is gather metrics. If you've got PowerShell-based build pipelines, it's really easy to inject metrics gathering code into your existing pipeline. Then also make the data visible. I've shown you the example at the beginning where we had these funny little spikes, not little, but these funny spikes in our production Jenkins instance. And just by looking at the data, we were really easily able to fix it. But we just didn't look at the data for a very long time. So be sure to make the data visible and not only collect the metrics. And then, of course, know the system, be able to debug every aspect of it. This is where things like debugging and event tracing come into play. With event tracing, we are really able to debug our systems in production. Event tracing is non-invasive. It might have like a tiny little bit performance implication, but if the system is already in a state we want to debug, go ahead, spin up a profiler, spin up a tracer, and take a log. You can, when you've got the trace, you can take as long as you want to analyze it, right? And be sure to know what to do when things go sideways. And please don't just restart the system and hope that the problem will go away. Okay? It's so hard to debug problems when we can't reproduce them. And it's not sad, although our systems are logical, and in theory, not in theory, even our systems are logical and are supposed to have persistent behavior. It's often very, very hard to debug problems when we're not in a production environment, when we're in a demo environment. So please be able or ensure to be able to debug those things, or at least profile them, trace them while you're in production. Sorry for taking so long, for overshooting time. I hope you enjoyed the session, and I'll be happy to take questions now. And even what would be really delightful if you've got some war stories yourself, come and share them with me. I'd be interested to hear what you're facing. Thank you. Yeah. So there has been a question. So you're using the MS Graph API?
Well, I was using like the anecdote module.
Yes. Yeah.
Basically, I was trying to get eligible Entra-ID roles.
Yes.
Of our users and allow them to activate it, like in the menu. To get them presented for the menu.
Yeah.
So I'm activating them actually. But because the modules were so slow in loading.
Yeah.
Eventually, just fuck it, I'll do it via the API instead, and I'll do it via the API because the module is just so slow.
Okay. 2
minutes to load, like the connect nggraph command and the actual command to get and activate the.
Okay. So there are 2 things I do here. First, so the question was the MS Graph API module, or the MS Graph module that's out there and then people can consume actively, has a pretty slow loading time in this case. For you, even better if it's not even. Okay. Okay. So 2 things to do here. First, in the environment you're using MS Graph API, be sure to set up some logging, best in a time series manner, to be to track if the logging time, if the loading times change over time. So when there's an update, you might be interested if it's slower or faster. So first, just to collect the data, and then to get down to the actual problem. So this would be the monitoring aspect. And now to the profiling aspect, use Profiler, PowerShell Profiler. Jakob's there. It's amazing session. It's amazing session. Just trace script. It's the command's called trace script, and you get a script block and import module there. Then you get a nice trace of really what's happening inside this module, and it might as well be that there's a dependency or a DLL loading that you can basically rip out or preload, that the whole thing goes up faster. And if Profiler does not work, sure, you can go and do event tracing. There it gets I won't paint it in a nice color, it's more complicated. It takes more time. But in PowerShell, when you're importing PowerShell modules, Profiler is top notch. So just trace script, use Profiler, and you most likely at least be able to see where all of the time is going. So maybe that's a good start there.
I had to pick between 3 sessions I'd like during that session. I picked another one, but I will watch it back. So
yeah, definitely watch the session from Jakob. It's a great one. Any further questions? I will take them outside anyway. So, okay. Thank you all for showing up. Thank you.